All right, so it's time to get started. Thanks everyone for coming so early in the morning at 8:30 in the morning on this Tuesday for TechEd 2013. I had a professor as an undergrad that for an 8 o'clock class, which I would inevitably have him for, who would walk in and say, "Good morning, everyone." One more time, "Good morning." Good morning. Thank you. He would also come in and give us a pop quiz, which I'm not going to do for you. So let's get started. This is TypeScript scaling up JavaScript, Dev B203, to make sure everyone's in the right room. My name is Jonathan Turner. I'm the program manager for TypeScript, the programming language. We'll be covering TypeScript at an introductory kind of level, talking about why we created the TypeScript language, what exactly TypeScript is, and what roles that it fills, and maybe touching on a bit on what's next for TypeScript. Before we talk about TypeScript, we need to go back in time about 18 years. There's a company called Netscape. They were starting to build this browser technology for the emerging World Wide Web. And there was a programmer named Brendan Eich looking at what could be done for scripting these web pages. Of course, if you think back in time, 18 years, what the internet was like, for those of us who remember that, it was very static. There wasn't a whole lot going on the web page. So a scripting language then would help, if you will, make a dancing monkey move around. It was make a button do something a little bit more than stay on the page, and for the page to come to life just a little bit. Brendan Eich, of course, made the programming language we know as JavaScript, which, since its creation 18 years ago, has grown considerably from that small scripting language for 100 lines on a page to something more like 100,000 or even 1 million lines of code. Sites like Hotmail, MSDN, Gmail, and so forth are using scales of JavaScript that were never originally intended by the author. Of course, to support this, we've had a cottage industry of JavaScript tooling that has sprung up since then. This cottage industry covers testing, covers some static analysis of the JavaScript code to make sure that the JavaScript is working correctly. Even tools like Closure, Google Closure, which allows you to, in the JavaScript code, write comments that give your intent, so that this intent can be checked. But the JavaScript language was never, because it was never originally intended to scale up to these sizes, really one of the things that we find out is that application scale development in JavaScript is difficult. It lacks the kind of features that we come to rely on as modern app developers. The kinds of features like classes for class-based object-oriented inheritance. It lacks a way of bundling up related functionality together. In JavaScript, the basic unit of abstraction is just the single function. In fact, everything is done with just single functions. You describe your intent to do object-oriented programming, to do class-style programming, by using a particular pattern in JavaScript. JavaScript also does not have tools that we need at large scales for composing modules together in a way that's composable and safe. It lacks a type system that can be enforced by a compiler. Now, JavaScript, when you run in the browser, you've either done sufficient unit tests, or the errors that occur when the user is using your application. So when teams at Microsoft tried to build large-scale JavaScript applications, they begin to hit a wall. And that wall is because when you build these large JavaScript applications, it's up to you to come up with a set of principles and rules that you follow, rather than a tool enforcing them for you. You have just the principles. And you hope that every team that you're cooperating with also follows the same principles. So teams at Microsoft came to the JavaScript language tooling team and said, is there anything that you can do to help us? Is there any tool that you can build so that when we build out these large applications, we can do so safely? We can do so in a way that we can share our code with other teams, and that teams can take that code, and then as these systems build up, we can continue to build on something that's very sound and very safe. And that's why TypeScript was born. TypeScript is specifically to address building these kind of large applications. JavaScript, it will have a way of just, we'll take JavaScript and we'll use some additional features on top of it, basically building out a superset of JavaScript that allows you to compile down to the original JavaScript, but has the kinds of features that you would need for this large-scale application development. But one of the key features here, too, is that we didn't want this technology to not be flexible and available across a wide array of technology. TypeScript, first and foremost, is something that's meant for every browser. The kind of output that you get from TypeScript is like you wrote the JavaScript by hand. TypeScript is a very thin superset, so that the code that you write in TypeScript is very much what you'll get out, and we'll see that here in a few minutes. It's also originally intended to work across any OS, any host. For those of you who are familiar with other kinds of JavaScript development. So originally we were talking about how JavaScript was intended on the browser when Brendan Eich was first creating it in Netscape. But now we see JavaScript on the server with technologies like Node.js. And of course, in Windows 8, we allow JavaScript to be used to build Windows Store applications. So JavaScript it will be used across now browsers, servers, and for client-side applications in Windows 8. And we wanted the TypeScript code output to be compatible across all of those platforms and into the future, any other possible future platforms as well. And the way that we do this, in addition to trying to be flexible up front, is to be an open source project. So from day one, when we were released in October of last year, we created an open source project on CodePlex so that people could come, take the code, could modify it, play with it, help us debug as we built up the features. So when we released in October of last year, we released a preview. It wasn't even the complete language, but we've seen people take it, modify it, add new features to the language, fix additional parameters, command line parameters to the compiler, and so forth. So we've seen a nice cottage industry of our own grow up around the tooling and supporting the TypeScript language. So let's talk about TypeScript a little bit more. So I said it starts with JavaScript. So when we built TypeScript, we wanted to build something that would be easily compatible with the JavaScript that's already available on the internet. If you grabbed some source code off a website, you should be able to copy and paste that into your TypeScript project. And then it should work just as you expect. We don't want a steep learning curve. In fact, we want a very shallow, simple learning curve so that you can easily convert code over to TypeScript. So because TypeScript is a superset of JavaScript, we have that nice compatibility layer. It also has this nice advantage that in TypeScript, you can call into existing JavaScript third-party libraries just as simply. Because of that compatibility between TypeScript and JavaScript, we've seen some nice synergy in the open source community. So there are what's known as typings. It's a layer of type information between a third-party JavaScript library and your TypeScript code. It doesn't modify the third-party JavaScript library, but it provides the type information that you can use for IntelliSense and for tooling. An additional part to JavaScript that we've added is that we've had the good fortune of one of the people on our team also being part of the ECMAScript 6 committee. This ECMAScript 6 is the future version of JavaScript that's currently being developed. And as part of the committee, he knew that classes and modules, that there is some new features coming to the JavaScript language. And we wanted to support those in TypeScript today. So as part of the TypeScript language, we are pulling in the ECMAScript 6 style classes so that the code that you write in TypeScript can compile down to JavaScript that's compatible across browsers, but also is future compatible, if you will. You begin writing and learning a style of JavaScript in TypeScript that will be possible in future versions of JavaScript coming down the line. We also augmented, I said before, TypeScript with its namesake, this type system. The type system is capable of describing JavaScript libraries, and we'll see that example here in a minute of what that looks like. The type system is good for two main reasons. It allows us to get good early error detection, so I can lay type information over classes and over functions. And if those are being used incorrectly, I'll see that feedback. We also can use it to get very correct IntelliSense. In the JavaScript language tools team, some of you may be familiar with the Visual Studio tools for JavaScript, and the good work that that team has done to build out the IntelliSense for the JavaScript language. In TypeScript, we knew that we could go a little bit better because we understood that in a statically typed language, like TypeScript is, that has the type information up front rather than at runtime, we have all that information that we would need for IntelliSense at compile time and design time, so we could give you accurate, precise IntelliSense. This type information comes at zero cost. So while you may describe your type information in the TypeScript code that you write, we will peel that TypeScript code peel the types out of the TypeScript code during compilation, meaning that we won't check the types at runtime and not have any overhead as a result. So this is specifically a design time feature is for the types, and then those are removed. And we end with the JavaScript language. So we start with TypeScript, which is the superset. During compilation, as I said, we peel off the type information, and we also take the classes and modules of the ECMAScript 6 standard that we've added to TypeScript and compile those down to ECMAScript 5 standard JavaScript. This is the JavaScript that's standard across all browsers, Node.js, and so forth. So you can use the features of future versions of JavaScript. You can get the IntelliSense in the tooling, but ultimately what it comes down to is that what you're creating is JavaScript. So I'd like to do a demo for what that looks like. This is the TypeScript homepage. For those of you who want to follow along, the URL is at the top, typescriptlang.org. This is a great place to get started and plugged into the community, start to learn the TypeScript language. We've got some tutorials on here. But what I'd like to show you is the playground. So what the playground is, you see on the left-hand side, we're going to have the TypeScript code. And then on the right-hand side, we'll have the JavaScript code that's being output. The TypeScript compiler and language service that we use in Visual Studio is compatible across operating systems as well. So we'll see that the language service and the compiler are both running in the browser. And that's because, of course, they too are written in TypeScript, compiled to JavaScript, and we can host them. So if I come over here you'll notice that I've written some JavaScript code on the left-hand side, and it's compiled down to the JavaScript code on the right-hand side. TypeScript left, JavaScript right. Can anyone tell a difference? Maybe nod your head. Right. So a few of you can notice that there are some white space differences. But by and large, the code that you wrote is the code that comes out. And that's the important thing here, is that if you know of techniques in JavaScript that are good for optimization, we would like you to be able to write that very clearly in TypeScript. And during compilation, we won't change your original intent. We want the code that you originally intended to be what comes out. So let's go ahead and run our example. I click this button, and it comes up and says, hello, object. So obviously, something is amiss. We didn't, of course, originally intend that to happen. So as I said, we have a type system in TypeScript. But as you can see, I haven't written any types anywhere so far, which means that the type system is completely optional. You may sprinkle in types as you want, but there's no requirement that you, as you copy JavaScript code, that you go ahead and annotate it top to bottom with all the type information you know. So now what I can do is I can jump in and I can annotate a particular set of parameters or variables with type information that I care about, and then let the compiler tell me if there's anything wrong. This basically gives me a dial to dial in how much precision and how much type information I want to feed into the compiler for that early error detection. You might use this, for example, at the boundaries of modules. If you prefer a very JavaScript style, inside of the module, you can do as dynamic as you like. And then as you interact with other teams, let's say, at the boundary, you may have that type information. The compiler will check that boundary, but then will allow all the code that you wrote dynamically to just pass through. And we see that here. There is some issue, but the compiler is just letting it pass through because it doesn't know about any of this type, the type information not being quite right. So I'm going to annotate this with our first type to see if we can catch what it is. Of course I know, and I'm sure a few of you have already spotted what the error was once you saw it. So in TypeScript, which is a little bit different than C#, you'll see that we put the type information on the right-hand side after a colon. As I've added this type, you now see that we get a squiggle for the greeter. And if I hover over that, we see our first type error. In fact, in TypeScript, these type errors are actually, if you will, type warnings. The compiler has still correctly generated the code on the right-hand side, even though that there's a warning, because to the compiler, it still believes that you know that your original intent was. And you wanted, if you wanted to pay attention to the error, you could, but we know that the code is still, once you peel that type information off, valid ECMAScript 5, and that's what we'll give you. So let's look at this error message. The error message says, oh, we've got a string on one side and an object on the other. The object has a single property called message that is of type string. So we have this disparity. There's a few ways we could correct this. So for one way, let's just fix this object literal to be a string. Once we fix it, you notice that red squiggle goes away and our warning goes away. And of course, if we run this, we get what we expected. Hello world. Let's actually fix this a different way. So let's go back to being a message. And then up here, let's say that this also expects message as part of an object. And then we'll reach into that and pull the message out. So this will also work. And what you'll see is we've just started to describe something a little bit more sophisticated. On the function greeter, we now are saying this is an object literal that has one property, message. In TypeScript, as you begin to describe these types and have to reuse them a lot, it may get tedious to build out large object literal types and copy them everywhere. So we give you a handy way of doing that called interface. So let's call this a greeting message interface, and then let's take the type information from this and put it into our interface. Again, you'll see that there's no curly, red squiggle, I should say, telling us those are any errors. And this actually might look a little strange to those who are more used to traditional languages like JavaScript or Java or C#, where an interface has to be explicitly implemented. Here, we've just said there's an interface on greeting as the type, and we passed in just a plain old object literal. So in TypeScript, this is a different style of type system than many languages. This is what's called a structural type system. It basically means if it looks like a duck and quacks like a duck, it must be a duck. It has the same features, the same properties, we'll treat it the same. And this allows you to more easily describe how the code from, say, third-party JavaScript comes in and has a particular shape. We can describe that very easily in the TypeScript type system. And just to show you how capable the interface is of describing different styles of objects, I'll go ahead and extend this a little bit further. So we'll say that this is, not only is greeting message have a property called message, it also is itself a function, for example, that takes a number and returns a number. And you may have seen objects like this in JavaScript, for those of you familiar with the JavaScript library jQuery. Maybe you're familiar that it acts, some jQuery pieces are functions that also have properties that also act like something else. Because of how flexible the JavaScript language is, it's easy to take an object and to begin growing it in very strange and interesting ways. So in TypeScript, we can describe those kinds of styles of programming in the type system. Let's go one step further. I want to show you this as well. So we can also describe an index that goes from, say, numbers to strings. So greeting message is now a function and an array, and it has a property. So you may think, well, I've never seen a JavaScript object that can do that. And that's true. JavaScript, you can't have something that is so many things. And this just goes to show that the interface style in TypeScript is capable of describing many, if not all of the shapes in JavaScript. Additionally, can even describe things that JavaScript, you can't even build out in JavaScript. So it's a very flexible, powerful way of describing the types that you expect coming in. So that's kind of a feel for the type system. Let's also take a look at the classes. So those of you familiar with C# and Java style languages, this should be immediately readable to you. So you may have had to read the code on the right-hand side before coming to JavaScript. And this is what I was saying before about you use functions to describe abstractions. Here we can use just a straightforward class style in TypeScript that's from the ECMAScript 6 standard. So we've got class, we have a greeting member just as before. We had a constructor that can create new instances of greeter and this greet method. You may actually, if you squint, recognize the right-hand side code. What we were playing with before is very similar to what is being output by the compiler. But here, we're using a much more familiar syntax for those of us from class-based object-oriented languages. Finally, I'd like to show you the module system. So in the module system, you can group related types and classes and functions together in a way that is behind a namespace and can be easily reused as a component later on. Here we have the module sayings, and we're exporting the class greeter. You'll notice if we don't export the class, we'll get a warning. So while by default, as we can see here, class greeter, all the properties are public by default, which may be different for some of you. But it's very, very normal to like a JavaScript style audience where they're not used to having kind of a sense of privacy. They are a public by default for their objects. In the module system, we are private by default, so we have to export the class. So we'll do that. Notice that we're, on the right-hand side, we're allowing you to write a very simple module, but we're beginning to generate code that is a little bit more sophisticated than you may want to write when you're just trying to get your ideas down. And so that's a nice advantage of the TypeScript compiler, is that it's going to handle that kind of code for you. And you'll notice too maybe that it has this interesting sayings or sayings something something. Those of you unfamiliar with this pattern, this is letting us know that this module sayings can actually be extended later on. We can, if you want, create another module called sayings and then add another class to this. This means that these modules are open-ended and allow you to grow them at compile time. This is very common in languages like jQuery, or I should say libraries like jQuery, because you have the original jQuery library and then you may have plugins that extend the original functionality. So the interfaces I showed earlier and the module system can be grown in a way that would be like a plugin system or an extension system. We see that we use the modules in a very straightforward way here at the bottom. So we just reach into them, sayings, dot, greeter, and so forth. I'm going to take a quick look over at Visual Studio, and you can see what this looks like in Visual Studio. I've got an application here. This is the Windows 8 sample for TypeScript, which you can find off the TypeScript homepage. So I can get the same kind of IntelliSense that I got before. So I could have a test string, I hit dot, and you see this IntelliSense start to light up. And not only that, we've got the description that this is actually a method off of a string. Let me pull that back up. And that what its types are, what it expects. And at the bottom underneath that, we'll also see some descriptive text. So for those familiar with VSDoc or XMLDoc, JavaScript has its own standard of documentation called JSDoc, which we support in TypeScript. So you can write in JSDoc to functions and methods and classes, and then as you light up that IntelliSense, we also give you that documentation. So that's really handy. So let's pop back over. You'll notice that, too, as you go through these samples, that we also support additional features on the classes. So here, let me see if I can make this a little bit easier to read. The constructor, we have a nice shorthand for the constructor where you can put public in front of each of its arguments, and then we will create that object for you. This is a nice shorthand. And underneath that, we also allow statics off of classes so that you could do, for example, vector dot times and get to that static member. So these are some good samples to work through and to play with and tweak as you're learning TypeScript. Just one last one before we go. I wanted to show you that we have in TypeScript, because of this ECMAScript 6 standard, we can do basic class-side inheritance or class-based inheritance. So here we've got the animal class, and then we will extend that animal class and create a snake. And so all of this inheritance will work as you expect. And then on the right-hand side, we're going to generate code so that what you expect is actually what's going to be carried out in JavaScript. We'll create a simple helper function. And in fact, this helper function is one of the few things that we will generate into the JavaScript code that you didn't originally write. It just captures your intent. So as I said, we released a preview of the TypeScript language, and that preview was open source, and you can grab it and take a look at the source. It's a nice example of using TypeScript in a large application. We also have the tooling. So I showed you that browser-based playground where you can go and you can play, and this is actually using the TypeScript language service and the TypeScript compiler. And we also, as I showed you, have the Visual Studio component. So these both use the same language service, but we also, on the Visual Studio side, have debugging support built in. This allows you to use a standard called the source maps that is compatible with Chrome and Firefox, and now it will be compatible with Visual Studio using the TypeScript plugin. So that when you output the JavaScript, it'll output the JavaScript with this magic link at the bottom that will lead it to a source map that will connect the JavaScript with the TypeScript that you originally wrote and allow you to debug directly on the TypeScript itself. So there are also a number of libraries. I mentioned before that, as you saw, we could use interfaces to describe the shape of objects coming in on the JavaScript side. You can create typings files which describe those interfaces between the TypeScript code that you wrote and the JavaScript, like, for example, third-party JavaScript libraries. And we have shipping with TypeScript typings for the JavaScript language API, for the HTML DOM. So you have nice typings against, for example, HTML canvas. We have typings for Node.js, for WinRT and WinJS, if you wanted to do Windows 8 application development. There's also the language specification for those of you who like reading those kinds of things. It goes into a lot of nice detail about the TypeScript language. So we released, as I said, in October of last year, and we've seen a really good community response so far. So over 2,000 Codeplex posts and so forth, you can see the numbers. There's been, in fact, this slide's slightly old. We've had over 200 feature requests. As you can imagine, there's quite a variety of opinions about, the nice directions that we could go. And it's really great to get feedback from the community. In fact, these feature requests are directly affecting the development of the TypeScript language. So I highly recommend, if you're interested in the TypeScript language, to come and give your thoughts. For example, one of the feature requests, one of the highest requested features is generics. Those of you who are familiar with generics in C#, it's a great way of describing components that are reusable, not just in the way that they connect together, but in what is passed into them. And we allow, in the new version of TypeScript that's currently in development, we'll allow generics in the language. There's also a number of other features that directly were influenced by the feature requests and the kinds of problems that people were running into in the wild using TypeScript. As I said, you can use these typing files, which are also known as DTS files. And we've seen a community of people spring up around creating these for a number of JavaScript libraries. So of the top JavaScript libraries, we now have about 90% covered. Again, this slide's old. There's around 200 library typings for various JavaScript libraries, Angular and Ember and so forth, that you can get at a repository called Definitely Typed. We see also people have been adding TypeScript support into tooling. So while we ship some basic ASP.NET support, people have taken it, created their own ASP.NET templates, have extended our support into Node.js. They've taken the testing framework Chutzpah and extended that to support TypeScript as a first party, and so forth. We've seen a lot of nice JavaScript tooling support begin to add the TypeScript. So before we go into questions, just to wrap, so we have a language that allows you to do application scale JavaScript called TypeScript. And that TypeScript language allows you to describe your original intent by annotating your JavaScript code with types, and allows you to write JavaScript code using new features of the JavaScript language, this ECMAScript 6 features. And those features like classes and modules allow you to describe reusable components that you can compile down to compatible JavaScript language that runs across any browser and runs across any host or operating system. So I thought we might have quite a bit of time for questions at the end, but I wanted to go ahead and open it up to see if anyone has questions. I know we've got some microphones up. Yeah, please go to the microphone so everyone can hear you.
How can you write TS compiler in TS itself?
That's the age-old question. How does the first C compiler get written in C? How is that possible? So what we did was we basically bootstrapped the compiler. So we wrote the first bit of the TypeScript compiler in JavaScript and then ran that. And once we had a little bit of a TypeScript compiler, we could write the rest of it in TypeScript and kind of grow from there. Yeah.
Could you compare TypeScript with Dart and CoffeeScript?
Sure. I'm not an expert in any way on CoffeeScript and Dart, but what I can tell you is that we basically, the philosophy that we use for TypeScript is we're approaching the same kinds of problems that CoffeeScript and Dart are approaching, but we're doing so in our own style, our own flavor. So Dart wants, for example, to describe web development in a way that holistically is different than what you would do in JavaScript. TypeScript wants to reuse as much of the JavaScript as possible, but give you a way of doing tooling and early error detection. And CoffeeScript is basically a Ruby-flavored JavaScript that doesn't have any typing at all. Good?
Is TypeScript, is it going to be part of the ECMAScript specs, or is it just compatible with it?
So there has been some kind of back and forth between the ECMAScript 6 committee and TypeScript. So for example, I showed statics in the TypeScript version of classes. And I believe those are being considered for the ECMAScript 6. So there's some experimentation that is being done by the TypeScript language that is feeding back into the JavaScript standard. But I think that TypeScript will basically be, if you will, kind of a proving ground of features. We're using the types in TypeScript, but I don't believe that JavaScript is ever going to support types because for them, they're more interested in the runtime behaviors.
How does TypeScript interact with a JavaScript bundler like Combris?
Oh, that's a good question. There have been some people, I think, experimenting with the bundlers. The key thing is, I think, that as long as whatever you're using to bundle things together understands source maps and can describe that then it should work. But I guess I haven't been using them directly. I've just been talking with people that have done it. Anyone else? Yep.
So can you explain what would happen in the scenario where somebody's looking at the JavaScript that you've generated, they make changes to that, how does that feed back into your TypeScript, or does it break everything?
Right. So if they modify the JavaScript code that's been output, you can, if you want, think about the JavaScript code being output as a binary. You know, if you think about C# and an IL file, or C and a binary, it would be like going in and mucking with the exe. It's not something that the compiler would catch that they've done. And you would need to go back and change the original TypeScript code to get that reflected in the JavaScript.
Can I generate? I'm here.
Yeah.
Can I generate TypeScript out of my existing JavaScript files?
So that's one thing that we would like to be able to do in the future, but really in general, it's not possible to take just a raw JavaScript file and generate TypeScript from that. Because the type information that we need is something that you have in your head, like the API that you want to put forward is something that only the programmer would know. We can't automatically do that in general. What we've seen some people do when they're moving large amounts of code from JavaScript to TypeScript is to annotate the JavaScript code. I showed you a little bit of that JS doc where I could give you some descriptive documentation along with each function. JS doc allows you to also annotate type information. So we can use that JS doc information and translate it to TypeScript. There are some efforts in the community around doing that. But as I said, in general, it's difficult. So you could only use it for targeted things. We've seen teams who had a particular style of JavaScript be able to do that. So that would be more of a targeted tool. Yep.
Can we put TypeScript in ASPX files, or do we have to put them in TS files directly?
Right. So you would have to put TypeScript in these TS files and then refer to the output JavaScript in the ASP. Yeah.
What's the strategy for debugging TypeScript? Would you debug the TypeScript or debug the JavaScript, or both?
Yeah, great question. So as you saw, the JavaScript output that we output is pretty readable. It's very close to the TypeScript in most cases. For being able to debug the TypeScript code directly, what you can do is you can pass a command line flag to the compiler, and that will output a source map file. The source map will map between the JavaScript and the TypeScript, and it's compatible with Chrome and Firefox, and with the Visual Studio plugin that TypeScript ships with, it also allows you to debug using the source map file. And so when you are in a debug session, you can set a breakpoint on the TypeScript code in Visual Studio, step, and you get all of the same debugging features that you would expect.
Okay.
Yep.
How does it work with bundling and minimizing?
So I think this might have been similar with the bundling question. For minimizers, minimization, we don't, so the way that we're kind of thinking about the TypeScript compiler now is as it's part of a series of tool in your tool chain. So you would output this JavaScript that has nice high fidelity with the TypeScript, and then you would call a minifier on the kind of the last piece of that tool chain. We've thought about adding minification to the compiler, but I think for now we just want to focus on that nice high fidelity output. Yep.
Do you have any examples or strategies around source control, like where this would exist in like a sibling or child relationship to the JavaScript files, also shared across teams, just your experiences internally to Microsoft, how you do that?
Right. So what we've seen, I guess, is people are checking in both the TypeScript and the JavaScript. To support that better, we would like to, like, for example, check out the JavaScript automatically so that we could compile and overwrite it as you would expect. What we would recommend up until then is just checking in the TypeScript and then treating the JavaScript as in like an exe file. So you wouldn't be checking that into your source code necessarily. Yep.
I realize it's still in the early stages, but at Microsoft, are you using this for any of your larger scale projects?
So we've announced so far that TFS, the TFS Online, uses TypeScript. There are a few teams, Social, which is one of the Fuse Labs experiments. It's kind of this cool social image site that uses TypeScript. There's a few other sites that are using TypeScript, and we're about to announce a couple more too. But yes, it is being used at Microsoft for very large applications, 200K plus.
So obviously, choosing to use TypeScript over just JavaScript for a very large application is a big decision. What does the roadmap look like for TypeScript with your development going forward?
Sure. So we're currently gearing up for a 1.0. So the current version that we're working on is 0.9. This is going to be kind of the rest of the features that we had planned but hadn't implemented yet. We're going to be putting into this 0.9. And then from there, we'll be driving into 1.0. Beyond that, I could only speculate. But what I can say, one of the nice advantages of the TypeScript language is its output. So if at any point in time you needed to, for example, go back and forth, let's say you needed to go to just having the JavaScript, you could take your output, JavaScript, and then just use that. It's like the JavaScript you would have written by hand. So it's basically a low barrier to entry, and it's a low risk to adopt TypeScript into your project.
I was wondering, this way, your left. Wondering how you handle, or if you handle multiple browser compatibility issues, or if you're strictly at the language and semantic level in your implementation.
Right, good question. So yeah, we do not, so the kind of code that we're outputting in the JavaScript is trying to maintain the JavaScript that you've written as TypeScript. If you've written code that is not, for example, compatible across browsers, we will not change it for you so that it is. Right? We're trying to maintain that fidelity. For the code where you've written classes or modules, you've picked a particular language feature, the JavaScript code that we output for those is trying to be a cross-platform JavaScript.
Okay, gotcha.
Do you support outputting comments? So for the use case where you might want to revert back to the JavaScript, you don't want to lose all your comments.
Right. So there is a comment preservation command line flag that you can pass to the compiler, and then that will take your comments and try as best it can to maintain the same location in the source file that you had in your original TypeScript.
Hi there. In your experience, how well would you say TypeScript sits with MVX frameworks, such as Knockout, for example, where I guess the structuring of the data needs to be quite well defined?
Right. So we've seen people that are using Knockout are using some of these frameworks using TypeScript. I'm not particularly an expert in that style, so I couldn't speak to it in detail, but we have definitely seen users using that, using the typings, and getting at least some benefit there. It does work. Okay. Yeah. Any other questions? All right. Thank you.